My name's John Lynn. I'm Cornell class of 93, College of Engineering, Mechanical Engineering. And welcome tonight. It's our first Tech and Entrepreneurship talk that I've organized, and hopefully making this a series. So if you know any Cornellians that want to be a future speaker to talk about tech or entrepreneurship, that would be great. I first met Tessa at a Tony Chen event, so I don't know if you guys know who Tony Chen is, but he's a class of 2012, and he's sort of like, I like to say, the Pied Piper of Cornell. He basically works for Cornell as a volunteer full-time, traveling the country, but mostly in the Northeast, to organize Cornell meetups and connect Cornellians with other Cornellians. So I actually had a friend that had worked at Dusty Robotics, and I was like looking at the background of the company. I was like, oh, Tessa's a Cornellian, you know? So when I met her in person, I was like, oh yeah, I've really wanted to meet you because I've have read about the robot as well as, and I was just excited to meet her in person. So. So I want to thank Peter Cooperstein, class of 78. He's the founder of Amici's East Coast Pizzeria. So he's the one that helped provide the food at a discount. So we're very appreciative of that. Amici's has restaurants in the Bay Area since like the 80s, I believe. And so yeah, let's. I'll be videotaping the talks, so I don't know about the Q&A and such, but we'll see if this becomes popular and maybe a regular series or not. But I want to introduce Tessa Lau, class of 95, co-founder and CEO of Dusty Robotics.
Hey everyone, welcome to Dusty. I am so happy that I can share this place with everyone and tell you a little bit about my story, about the company, what we're doing here. So Dusty Robotics, so let me tell you a little bit about me. John, sorry if this is like repeating some of the questions you're going to ask later, but it'll help you understand how we get to standing here with a robot in the construction industry. So I graduated Cornell in 1995, did my PhD in computer science at University of Washington. Actually, I studied AEP and CS, if you guys are familiar with that, because I love to understand like how the world works, so I couldn't decide between understanding it and building it. I ended up building it. So I did CS, AI for my PhD, went to IBM Research for about 11 years, doing business process automation, so using AI to understand human behavior, capture and repeat it. And then I got into robotics. That was about 13 years ago at this point. I left IBM, I joined a company called Willow Garage. That was the premier research lab for robotics at the time. That was in Menlo Park. I joined them about 11 months before they went under. So I got to learn about robotics, which was awesome, but couldn't, unfortunately it didn't last as long as I thought it would. And so a lot of us at Willow Garage were really excited about getting robots into the real world. And so we decided to start a company together. So my first robotic startup was a company called Savio. If you've ever stayed at a hotel and you had a 3-foot-tall R2-D2-like robot deliver a sandwich to your door, that was probably one of ours. I was the CTO. I programmed most of those robots, helped design them. Definitely spent a lot of time on elevator robot interaction, ERI. Very, very complex things, but I loved it. It was so much fun. Unfortunately, Savio didn't really make it because we didn't have product market fit. And so we weren't building something that the industry actually wanted. It was more like a vitamin than a painkiller. So after 5 years of that, I decided to start another company. So my co-founder, Phil, and I, we were both working at Savio at the time. We decided to start a new company in robotics because we're both roboticists. And I happened to be remodeling my house at the time. And it was my first time seeing anything in construction. I thought everything is automated because I'm a roboticist, and my car is a robot, my cell phone gets built by robots, but my house was not a robot, far from it. It was actually built by people on their hands and knees using power tools. And so I thought there's got to be something that robotics can do to help automate this industry. Because like my project took twice as long as I thought it should, it took cost 3 times as much, and that happens all over the place with every single construction project. And so I started looking into construction. I bought a hard hat and some steel-toed boots, and I started walking around on construction sites. And one of the first projects that I set foot on was on Stanford campus. I was talking to the project exec who was building out the graduate student residences, EVGR, if you're familiar with those. And he told me that there were 1,000 people on site that day, and that his job was kind of like a kindergarten principal. He had to make sure every single one of those people showed up for work sober, that they went to the right place and they did the right thing. And if they effed up, it was his fault, and he had to fix it. And that was his job. And his hair was going gray, and he was really stressed out because they had just discovered that there was a problem with all of the bathrooms on this project. Imagine a dorm building, there's lots of bathrooms in it, and every single one of those bathrooms had to be redone because of a mistake. And so he was trying to coordinate all of that work, and he was worried he wasn't going to be able to turn it over to Stanford in time for the fall class to move in September. And so he was really worried. And I realized that that is the problem in construction. Construction has an orchestration problem. They need to be able to coordinate the work of all of the people on site so that everyone does the right thing. And the way they do it today is that once they've designed the building, they print it on huge sheets of paper, hand those pieces of paper out to people in the field, and every team has to make their own marks on the ground. And they do that by snapping chalk lines. If you haven't heard of a chalk line, it was invented by the early Egyptians 5,000 years ago. It's a piece of string dipped in chalk. You stretch between 2 points, you snap it, that leaves a little line of chalk dust on the ground. So you can imagine how much measuring has to go into actually marking out all of the things that are going to go inside the building. Well, that gets done manually by people today before Dusty. And so what we're doing with this system is creating this orchestration platform that tells everyone on this construction site what they're supposed to be doing. Because today, almost 90% of the people in the field don't have the information they need. They're struggling to build the building that they want to build. They want to use their hands. They want to assemble this thing. That's their job. But most of the time, they don't have the information they need. And it's because it's so painful to get that information out onto the ground. And so what we've done is we've built a robot, or actually it's a fully integrated end-to-end system, including software and hardware, but today I'm showing you the robot part, that actually takes the digital drawings of your building and prints them full size on the ground. And the reason that's important is because if you don't have this, you are at risk of making lots of mistakes that cost you lots of time and money. So let me start going. So before I start, there are 3 components to the system. There's the robot that you guys are seeing here. That is called a laser tracker. It is a high precision optical positioning device, and it tells our robot where it is. And we've got this iPad here. On this iPad, I've got the CAD of a building. And what I've just done is I've used my finger to select a couple lines and say print. And now our robot is going and printing all of that information on the ground. So this information was collected from all of the different trades. So in construction, you have drywall trades, you have mechanical, electrical, plumbing, fire, pretty much anything that you might install inside of a building, there's a trade that installs that. And in order to do that, they first mark the ground of where they're going to install something, and then they come through and install it. And that includes everything that gets built, not just on the floor, but also in the ceiling and in the walls. All of that has to get marked out on the ground before they install it, because you need to know where and what to install. And so what our robot is doing is it's taking all of that information for all of those different trades and printing it on the ground in a single pass. We're doing this in about 1/10 of the time that it would take normal trades to do this. And so we're massively speeding up the process of construction. And we're also doing it with 100% accuracy. So our system is the most accurate mobile robot on the planet right now. It's printing within a 1/16 of an inch of exactly where it's supposed to be. And it's guaranteeing you that exactly what is in your plans is what you built. Because if it's on the floor in front of you, construction becomes more like paint by numbers. It becomes so easy to build because all of the information is laid out right under your feet. And so we're making construction so easy to do that we're eliminating all the mistakes that happen when people are manually interpreting drawings, they're manually making measurements, or the information they have doesn't agree with the guy next to them, and they have to figure out who's right. And so we're eliminating that entire class of errors, and that causes buildings to get built right the first time, which is saving months off of the construction specialists. And so some of our best customers are actually using Dusty to open up the facility sooner. We helped build the Sutter Health facility in Los Gatos. They used Dusty to do what we're calling multi-trade layout, and they were able to turn over that hospital to Sutter 3 months before schedule. And that's huge. If you're building any of these facilities, right now we're doing a lot of data center work, and so if you think about all this investment in AI, and you've probably heard that data centers are obsolete before they even finish building them, well, if we can help them build those data centers a couple months quicker than before, then they get more return on that investment. They get more use out of that asset that they're creating for their company. So a couple things about what we're showing here. You can think of this as a jigsaw puzzle that's coming together piece by piece. What our robot is doing is it is taking the drawing on our iPad and it is deciding in what order to print everything. And so it looks like it's doing a little bit here and a little bit there. What it's actually doing is it's trying to minimize the time wasted while it's traversing the floor. So in construction, time is money. And every single moment that our robot is moving and not printing, it's actually wasting money and time. And so what we're trying to do is optimize the order in which we're printing things in order to maximize the efficiency of this process. And so what it'll do is, as soon as it finishes printing a line, it will figure out where's the closest thing that I can move to next, and then I'll print that. And that way it's trying to maximize the amount of time it's spending actually making marks on the ground, which is creating the highest efficiency for our customers. All right, let me pause there and ask if there are any questions.
Does it need to have light? Do you want to run at nighttime when nobody's around?
Yeah, it does not need light. It can work in the dark, but it does require an operator, and people need light.
How tolerant is it of surface roughness or tilt and grade in the surface?
Yeah, so we've worked on slanted and rough surfaces. We did all of the parking garages at LAX Airport. So if you've ever flown in and out of LAX and had to park there, you've probably parked in one of our parking garages. So that's like a slanted floor on really rough, heavily asphalt. This design is designed for flat surfaces only. So this particular design wouldn't work on like a dirt surface or anything like that, but we do sloped roofs, we do slanted floors, anything like that. The surface doesn't have to be too clean. Right now here we're on whiteboard because our landlord doesn't like it when we print on his concrete. So we needed something that we could erase, that we could keep doing demos over, but normally we would be printing on something like a concrete surface like the floor right here.
You sell the system or lease it, and who's the customer?
Yeah, so we sell to primarily general contractors. You can see a lot of our logos on the hard hats up there. Those are all the people that we work with. We lease the robots as a subscription.
So is it integrated with other construction software like Autodesk and all that?
Yeah, so we integrate primarily with Autodesk tools because the designs that we print are actually generated typically in Autodesk, AutoCAD, or Revit. And so we have plugins that integrate with those tools, and we're also working on more plugins with Procore and ACC.
What is the market size you think it will be?
Yeah, so layout happens on every single construction project, big or small. Which means that this is a critical path task in every single construction job. If you're doing something like a bathroom remodel, you might not use a robot like this right now, just because it's faster to just do it by hand. But we've done anything as small as a single family home, up to anything as large as the Raiders Stadium in Las Vegas, and as well as lots and lots of data centers. So our sweet spot tends to be those more complex, bigger jobs, but this technology is useful on pretty much every construction project. And so construction is a $2 trillion industry in the US alone, I think it's like 10 times that globally. And so if you figure like 1% of that $2 trillion is unmarketable.
And now ask what's the cost comparison with human beings?
With what?
The cost comparison with human beings doing
Yeah.
the work.
Yeah, this is, so we're much faster than people, just because robots are way faster than people with measuring tape. And so if you do like a labor cost comparison, we end up about the same. If you think about the value that we're creating, we're way higher.
So, I'm curious about the software, right? So you said the creative itself
Yeah.
is done on Autodesk and you import it into your software.
Yeah.
So for your system, is it mainly on the optimization of the routing and the quickest time for the robot to finish the joining, or what else are you doing with your software?
Yeah, so what our software does is it allows our customers to collaborate before they get the film. So after you design, so the way it works in construction today is that every trade does their own design. So if you're the framer and I'm the mechanical, and John is doing the electrical, then we're each doing our own design. We come together and we coordinate and make sure we don't have any conflict. Dusty software supports that process. And so after you design it with an Autodesk tool, you bring it into the Dusty portal, and then we help you figure out what gets printed, how it gets printed, as well as any conflicts that might happen can be identified in our portal. You can fix all of those things before you commit it to print. And then once you commit it to print, you're using our robot, you're using our iPad. After you print, you're using our portal again to get information about the productivity that you achieved. And so that productivity helps you estimate how you're going to do your next job, which means that we can help you lock in your profit margin on your next job, because we can tell you how you did on all the past jobs you did with us.
For very large square footage projects, do you deploy more than one robot for
We can. Yeah, we've had up to 4 robots working in the same building at the same time.
with the same operator, or just different operators for each?
We actually had one operator for that. He was a little bit frazzled. That was because that was early on. Nowadays, we've seen single operator, 2 robots, no problem. That's more common.
Chalk lines can be redrawn afterwards if you make an error in design. How you erase and redo this if there's an error.
Yeah, well, how do you redraw chalk lines?
Dust it off.
Yeah. So you can actually wipe off the ink in some cases, right? We have different kinds of ink.
Off of cement.
Yes, you can scrape it off basically. It doesn't actually penetrate too far. Depending on which type of ink you use, some are more permanent than others. The more common way to, depends on the size of the redo. If it's too large, the same with chalk, you might use concrete colored spray paint to just like paint over the ground and then lay it out again. That's one of the things you can do with Dusty as well.
The construction industry is very slow moving, as you mentioned, they're using archaic ways of doing this in the past. How do you convince and move them to this kind of technology?
Yeah. We have gone viral on many occasions because the value of what we do is so obvious. Anyone who's done layout, has anyone here done layout before? Okay, that's awesome. All right, so anyone who's done layout before knows it's horrible. You're on your hands and knees, you're constantly worried about making a mistake. One of our foremen loves us because he can sleep at night. Before Dusty, he was up at night worrying that he made a mistake, he's going to bankrupt his company. And so layout is typically done by some of the most highest paid people on the job site, because they're the ones that have the most experience to actually do it right. And so anyone who's experienced layout, whether they've done it or whether they've seen it done, know what can go wrong when someone makes a mistake. And so as soon as they see a Dusty robot doing the same thing, it's immediately obvious what that value prop is. And so recently we've had a couple videos go viral. The most recent one got about 20 million views, got reposted by a number of civil engineering networks and other things like that. And so that's how people find out about us, and as soon as they see it, they become very interested in being a customer.
Do you provide it as a service too, to try to transition these people?
We have partners that actually do provide a service, and they can hold your hand and walk you through the process of getting up and running the testing.
Thank you.
You said earlier about walls and ceilings?
Yeah.
Is that a separate machine?
No, so let me walk you through what we're seeing here. So these solid lines here, those are what's called bottom track or top track. So that would be where a wall would go. And so someone would install a wall over top of these parallel lines here. There's more walls that go here, and likely going to be some pipes coming up in that space in between. That's all the chase. So that all goes on the ground. It gets installed vertically. But then we also have things that get installed in the walls. So right here it says card reader. So you're not going to install that on the floor, right? You install that probably about this height. That's how you would badge into your doorway. We have things that get installed in the ceiling as well. So this curved line here, this is a conduit run. So that would plug into that chase there. And here, this point, it looks like a little cross with a symbol around it. That represents what's called a hanger. So that would get installed in the ceiling overhead. And so typically someone would put a plumb laser down on that point, shoot it up overhead, and then install a hanger hanging from the ceiling overhead. And that would hold this conduit run up, suspended from the ceiling. And so things that get installed either in the walls or up above also get printed on the ground. And so we're following the existing common practice in construction. We're just replicating what they're doing and doing it faster and more precisely.
So,
Yeah.
I think there's a question
Oh,
over
whoops.
there.
I was gonna say, so how many sheets of the construction set are actually gonna be painted here?
Yeah.
I mean, all
could
the
be all of
subs? It could be all of the
It could be
subs.
all of them.
So it could look pretty darn busy.
It could.
Do you typically sequence with the phases of construction so that you're saying, all right, let's paint
Yeah.
these subs, mechanical, electrical, whatever, and then we'll come back and we'll do?
We can do that. What we usually do is print for the major trades, and then everyone else just, follows along on their own.
Right.
But it depends on what our customers want to print. Some of them are printing everything, including the kitchen sink. Others are just saying, well, I only want to do the walls to start. They will eventually start adding in more and more of the stuff as they see the value and as they get more comfortable with the system.
And what's the learning curve for a GC team, and how long does it take them to get comfortable that they can trust that?
Yeah.
And that everything that's down there is exactly what it needs to be?
Yeah. What we usually see our GC customers do is start with one pilot project, deploy it on that project, and learn about that process. This is not just a drop-in replacement for what they're doing. It requires a little bit of process change for them. It requires them to do business a slightly different way. From how they contract with their subcontractors, to how they design and model the building, to how they sequence the work that happens in the field, right? And all of that are changes that have to happen at the GC level. And so they'll start on one pilot project, learn what all those changes are, and then apply those to the next projects.
Does the manual way of doing it put the words?
Have you ever tried to write on the floor with a Sharpie? It's really hard. I've done it. So you can write words on the ground yourself if you want. My handwriting sucks. I'm sure everyone else's does too. And so the reason people don't tend to write a lot of words is because it's hard to do and it's just painful. And so the clarity of what we bring here is one of the reasons this is so important. Robot's handwriting is always the same. It's always legible. The kind of information we can bring out is just so much richer than what people would normally have today. And if you think about it, every single word that we print on the job site is a mistake that doesn't happen. Because we're providing more information to people who wouldn't have that information otherwise, or maybe they would have to go find it. It's written down in the trailer somewhere, and no one wants to hike all the way back to the trailer just to find one bit of information, so they'll guess, or they'll make a mistake, and that happens all the time. And so by bringing all that information out, we're eliminating all those possibilities for error.
What happens if it gets kicked or hit? Construction sites are busy places and people are dropping and... Come on, give it to me.
So it's getting its position from the laser tracker right there.
There's a seismic amount. Oh, okay.
Yeah, and so that's, it's getting 20 measurements a second from our laser tracker. And so even if it gets, off track for a little bit, it'll quickly get back on track.
So does that need to be precisely placed?
Yes.
How do you do that?
So the way the construction process works is that you get surveyors, licensed surveyors, to come out and give you points around the perimeter of your building. Those are placed at known locations, both in the real world as well as in your digital file. And so with our laser tracker, we scan in the positions of 3 or more of those points, and then we triangulate. And so that's how we know where we are.
So I noticed the wheels are sometimes tracking the ink around. Is that a
Yeah.
side effect of the whiteboard, or?
That is a side effect of the whiteboard. This doesn't happen on concrete. We were trading off between something that's, so the other option here is that we can use brown paper, but then we go through rolls and rolls of brown paper. So we try to save the planet a little bit and print on the whiteboard. This particular ink and surface it tracks, unfortunately, but that's the trade-off we have.
Can you tell us about a project, maybe an early one that didn't go the way you expected?
Oh yeah, we've got plenty. One of the earliest projects we did was actually in downtown San Francisco. It was on Market Street, and it was a project for Swinnerton. They were still a customer, even though we messed up majorly. And it was I think the building's up now. It was a Whole Foods with some apartments on top. And so they said, come in, do a demo for us on the Whole Foods. And I said, great, right? That should be a great demo. It was really early on. I think it was our 3rd time bringing the robot out of the lab and into an actual office or actual project. And so it required 2 engineers with laptops to actually run the system. And so we got to the floor. What we didn't realize is that the only access to the floor was up a ladder or down a ladder. And our equipment came in 100-pound cases. And so we were lucky that someone knew how to tie knots, and we could actually lower it down with a rope. But anyway, lots of learnings. The biggest problem that we had on that job site was we were printing the wall that goes between the bathroom and the main part of the store. And it was supposed to be the straight line, straight down the middle of the building, really easy to do. Just like this thing should be able to do it, no problem. We were so confident in our system. And so we programmed it all in. It took us like a long time to get things set up because it was really early and the thing didn't work as well as it does now. And we finally got it set up and the robot started printing. And we noticed that instead of going straight, it was actually like veering off. And the superintendent got really, really mad. And like he started like, as the robot kept veering off, he got like more and more red. And eventually he just started screaming at us like, shut that thing down, get it off my site. And so we packed up and we left. And we came back to our office and we said, what the happened? It turned out that all of our testing had been in our office. And in downtown San Francisco, if you look up, we were in the pit of this big construction project. If you look up, there's all these apartment buildings around you. Every single one of those windows has a Wi-Fi that's broadcasting right at you. And so it turned out we were using Wi-Fi to connect between the robot and the laser tracker at the time, because of course, why not, right? Wi-Fi works. But when you have a lot of Wi-Fi congestion, then there's a lot of unpredictable latency between the positioning device and the robot. And so the robot was getting delayed information about where it was, and therefore its control system was planning an inaccurate path because it had incorrect information. And so we didn't realize that at the time. We didn't know what was going on, but it took us a while to debug that. But we're no longer using Wi-Fi.
2 questions. First, could you shed a bit more light on what the human operator is doing with that iPad? And yeah, I'll follow up with the second question.
Okay, so I'm going to walk around and show you guys all what's on the screen here. So this is the CAD file. You can see the robot moving around. You can see some green lines. That's what it's planning to print next. And so what the operator does is that they just take their finger, they highlight a bunch of stuff by dragging it on the screen. The stuff turns black and then green, and then that's what the robot's going to print. And so operating this device is actually kind of like playing a video game. It's pretty easy to use for anyone familiar with iPads or technology. We've trained everyone from a 17-year-old carpenter apprentice to a 60-year-old superintendent, and even the non-tech savvy people have been able to figure this out. So we've made it as easy to use as possible.
Does the operator need to focus on the iPad throughout the entire?
I haven't even been looking at it. I don't know.
Yeah. Got it. Yeah. The second question is, and I already touched on it a little bit. Could you tell us a bit more about your pivotal point throughout the iterations of the product as it improves over time?
So over there behind Greg is our museum. Those are our first 2 prototypes. One of those was one of the ones that made that mistake on that job site in San Francisco.
You're fired.
They were mostly 3D printed. The base was an off-the-shelf robot base that we just bought from a company called Robotics. That it basically gave us the chassis, the blue chassis, the wheels, and motor controller that would move them. And then we 3D printed like the shell, the orange stuff around it. If you open them up, you can lift the top, and there's like a jumble of wires inside. It looks like a science experiment. So that was our first prototype. And we did that because we wanted to learn, what does this thing need to do? Because we had no idea. And so what we did was we tried building something, and every month in 2019, which was our first year of operation, we actually took it out onto a job site and actually did something with it. The very first time we did that, all it could print was an L shape. Like we programmed in like a 3-foot by 9-foot L. And we showed that to someone and said, hey, what do you think? And they're like, I don't need an L. But they gave us feedback on the quality of the printing, on the line thickness, on the straightness of our lines. It wasn't very straight back then. And so we learned what worked and what didn't. We took that back to the lab. We made another prototype. Next month in February, we went out and did that again. And so we kept iterating. Those 2 robots actually did our first paying job. So our first paying job happened after about a year of doing this like piloting. We were just trying the robot on all these different job sites, whoever would let us come out and do a test. And eventually I found someone who was building a medical office building for Facebook in Menlo Park, and he said, okay, you guys can come out and do a test. It was about the size of this building, all like gutted, just a total open floor plate with lots of pipes coming up out of the floor that they were gonna connect sinks and toilets to. And we were like, oh my god, this looks really hard. So we'll try it. And so we spent 2 days on that site. It was still run by engineers at that point. So our entire company actually went out to that site to run the robot. I remember there was a bug in our system, which every time you reboot it, it would take it would have to replan everything that it was doing. And if the floor plan was large enough, this was like an NP complete problem, and it would take like an hour to plan out its path. And so we were almost done with this floor on the second day, and then the system crashed, and we had to start over. And so we were almost done. We had to print I don't know, 4 more lines, but it crashed, and so we had to wait that hour for it to replan and get up and running again and print the last 4 lines. And so we did that. We went back to our customer and said, hey, we're done. What do you think? How did we do? And he said, oh my god, you guys actually did really well. This is exactly what I was hoping for. Send us an invoice. Oh. And I was like, what's an invoice? I had to Google, creating an invoice and find a template for actually charging money to a customer, because I didn't know how to do that. And I didn't know how much to charge him. And so I said, well, how much do you think this is worth? And he said, oh, $5,000 sounds about right. And I was like, oh my god, $5,000. So that check is still on our front desk, if you want to see it. That was our first paid job, and that was in January 2020.
Are you outside the US as well, and do different regions, countries have different standards than you are?
Yeah. So right now we are North America only. So we operate in the US, Canada, Mexico. All of the construction is pretty typical in those countries. What we've seen is that in different countries there are likely going to be slightly different construction processes, but not too different from what we've seen. But we haven't really explored too much yet.
Next stop, Japan?
Next stop, Japan, maybe. There's a lot of demand in Japan.
How much of the equipment is custom manufactured versus off the shelf?
Yeah.
And do you manufacture and assemble it, or do you outsource it or combine that?
Yeah. So of these 3 systems, obviously we don't make iPads. That device is called the laser tracker. It's off the shelf. It's manufactured by Hexagon. It's a positioning device. It's a metrology device, actually, that gets used to measure, think about measuring satellite dish curvature. So it's accurate down to 15 microns. It's actually overkill for what we need it for, but it's the only device on the market that gives us the accuracy we need in order to provide a 1/16 of an inch accuracy to our customers. So we primarily manufacture the robot. We actually have a contract manufacturer in Fremont here that builds them for us. We built the first So that one back there, that is our first gen field printer. This is a field printer 2. So the first 60 of the field printer original units were built here in-house in this office. And then the remaining ones, as well as all the field printer 2s, have been built with our contractors. Yeah.
What would happen if there were pipes and some partially built walls and whatever? Obviously, you couldn't do some of that close-in work next to a wall, so how do you deal with that?
Yeah, so it actually can. Let me see if I can show you. Looks like there are obstacles over there. Let me pause. Actually, let me give you a tour of the robot while we're here.
You want me to grab the column pencil?
Sure. So, what you see here, the eyes are my idea. I call them robot self-defense. Because it's got to be cute, otherwise no one's going to want it on the website. Anyway, under the front hood, we have 2 ink cartridges. Each of these ink cartridges last for about a couple floors, and they actually spit out ink. And you can see that this tray can actually move left and right. And so what that lets you do is, if you need to print up really close to a wall, you can actually slide the tray all the way out here. And so we can print within 1.5 inches of any obstacle like that, or like a wall, or like the edge of your slab. And we designed that on purpose because if you think about it, where do the walls go inside a building? They go next to all the obstacles. They don't go in the middle of the room. And so we actually knew that we had to build a system that would actually help us, or help our customers be able to print as close to the edges as they possibly could.
Now, do you have to tell it wherever all the walls are, or does it sense them?
It senses them.
Okay.
So as we've been running, the system actually has a number of sensors in the forehead right here under its eyebrows. And so there's a depth sensor in there that's actually creating a point cloud of all the stuff that it sees in front of it. We also have obstacle or cliff detection sensors both in the front as well as in the rear. You can see these 2 things back here. Those are looking for both obstacles like this as well as drop-offs where the robot might plummet to its death. And so we want to avoid that, and so all of our sensors are made to keep it safe.
Follow on Raj's question, do you consider entering emerging markets like China or India where construction is a huge demand?
Yeah, absolutely. We see demand from all around the world for this thing. I mean, we've had inbound from, I don't know if it's every single country, but it's very close. And so, but you know, we're a small team and we can't afford to service the entire world yet, but we are planning to go international at some point for sure.
The other question is, have you ever considered enter other industries? For example, the floor cleaning?
Yeah. Well, the reason our company is called Dusty is because when we were first thinking about what we would build for construction, one of our first ideas was a vacuum cleaning robot. It was, you know, we didn't know construction, right? So we were trying to come up with what would work best for this industry. And every single job site needs to be cleaned, right? There's dirt and dust everywhere. And so that would be needed by every single job site. But we realized that that is not as valuable as what we're doing today because no one's going to pay extra to have a job site extra clean, right? Whereas in this case, the amount of information that we can bring out onto the site is just so much more valuable. And so we named the company Dusty because we thought we were going to be something else.
At this point, what is the biggest pain point or the friction for further adoption, both internally and externally?
Yeah, biggest pain point for adoption. One of the challenges that we're struggling with right now is, I mean, we touched on the change that has to happen when GCs adopt us, and so that it means that getting people to adopt this requires a lot of change to happen in the industry. And so that is something that I wish we could make accelerate faster, and we're still trying to figure out how to make that go faster.
So you mean the process change?
The process change, yeah. I mean, if you want value, you have to change how you do things. And so, you know, we're helping our customers see that when they do it this way, they're able to de-risk it, they're able to get their buildings faster and everything like that. And so what we're doing is slowly accumulating the proof that this is happening. And I believe that this, eventually we have so much overwhelming proof that this is just inevitable. It's going to be on every single job site, but we're building towards that.
What about internally?
Internally.
Yeah. From your team, company, stack.
There are a million things I want us to build. Which one do we pick? That's one of the challenges. There are so many things that we could do that would provide value to our customers, and so you know, our engineering team is really good, and they can do a lot of things, but they can only do one thing at a time. And so, how do we choose where to invest our resources? That's one of the challenges we have internally.
Then what is the biggest milestone at this moment?
So one of the things we're really excited about right now, I didn't talk about these QR codes, but you've seen that we've printed a couple QR codes on the floor here and there. You can't print those with a chalk line. And so that's one of the things that differentiates Dusty from how things were done before. One of the things that we're really excited about is those QR codes are the gateway to much more information. And not just one-way information, but actually two-way information. And so one of the things that we're building next is actually having that QR code actually link to the AI that we can deliver to the construction industry. So if you're, one of the key metrics in construction is time on tool. If you've got someone in the field who's working, how much of their time is spent actually using their hands to operate a tool, to build, versus how much time is spent looking for information or calling someone on the phone or trying to do something that's not directly related to the building task. It turns out that over a third of the time in construction is wasted, it's not on tool. And so by bringing AI out into the field through our QR codes, we can actually increase time on tool and make people a lot more productive by using AI to automate all the stuff that they have to do that's not directly building the building.
Can you talk a little bit more about your sales process? Do you feel like it's more effective for your sales team to acquire those customers, or you mostly go organically and trying to get more and more?
Yeah, so our strategy has been to create the best brand in construction robotics. And we've succeeded because we are now the poster child for construction robotics. Like if anyone Googles construction robotics, we're the first thing that comes up. A lot of people have heard about us in the industry, and so we have like the biggest name recognition out there. And that was deliberate, right? That was not an accident. So the way we acquire new customers is that they hear about us, or they see us on on their friend's job site, or some of our videos go viral. I said I put the eyes on the robot for a reason, right? We've created a personality. We've created this robot that looks cute, and it's and the value that it demonstrates is obvious once you start watching it do its thing. But it's also very distinctive. You can tell it's a Dusty robot, and so. By creating the best product on the market, by having a marketing strategy that establishes us as the thought leader and shows that we're providing real value to the industry. We're not doing pilots, we're not like running experiments, we're actually doing real work for our customers. We're creating those proof points that make people realize, hey, this is real, this actually works, I want this on my next job site. And we combine all of that with an investment in customer success, which means that we're not just dropping this on someone's construction site and saying, there you go. We're actually helping them through that change management process. We've created this unstoppable solution that everyone in the industry is going to eventually adopt.
Yeah, if I think about the life cycle of a construction project, 18, 24 months, you're adding a lot of value to the layout process, which I'm gonna guess is 2 to 3 months. You're probably making it a lot faster. Like the assets that a customer have, most of them are going to be dedicated towards the construction portion. There's a lot of white space now. Like eventually you can see a place where you're kind of oversaturating the customer's ability to keep doing new projects. How do you think about that from a retention standpoint? If a piece is going to be for a small portion of their value chain.
Yeah, well, that's why we're investing in everything that comes after it, layout. And so these QR codes are key to that strategy because all of this layout lasts the entire duration of the construction project, up until the last point where they put in the flooring and all of this gets covered up. And so during that time, while that installation is happening, everyone is building off of these marks that we put on the ground. That is why we want to provide value to our customers at that phase through these QR codes and through our future AI solutions.
So is there a subscription then continuing on after the layout phase, like from the other value added software?
That's the idea.
Okay.
I have 2 questions.
Could your robots bring the tools and material to the people standing where the work is to be done?
Maybe someday.
And
It turns out 20% of their time is actually spent trying to find materials and going to get tools. So that's a valuable part.
yeah, you need a lot more robots than all the 2x4s around or whatever. I imagine you could just print this whole thing back and forth once.
Like a lawnmower.
Yes, if you
Yes.
projected it all over a raster and you just
Yep.
printed it.
We
Does
could.
that not work well?
So this is a demo file that we printed here, and it deliberately has a lot of information on it. In the real world, it's not this dense. And so a rasterization probably wouldn't make as much sense. We deliberately crammed a lot of information into this file because it prints too fast. Our robot's too quick. And so when we do demos, it would be done in 10 minutes. And then I'd be standing here with like, nothing to show you. And so we deliberately created a really, really dense demo file, but this is, this actually would probably take a crew probably a week to actually mark out everything that you see here, and we did it in like half an hour.
Two more questions. One is there any aspect of the AI component that helps with error correction? In other words, if there's an error in the construction set,
Yeah,
the error gets translated.
that's right, that's right.
And so this doesn't have the ability to sort of
Not
say,
yet.
wait a minute, that doesn't make sense.
Not yet,
Okay.
yes.
To resolve.
Yes, so it's like a
construction.
printer, right?
Right.
If you print your essay on your printer at home and there's a typo in your essay, your printer's not gonna catch it for you.
Right.
And so the same thing with our printer, right? It won't catch errors in your construction drawings yet.
Understood. And then the follow-on is that, how does it work when there is, to this gentleman said earlier, when there is already some infrastructure or structure in place? Because you must need more than one of those hexagon machines, because if that gets behind that fake girder or iron right there, it loses the
Line of sight.
line of sight,
Yeah.
which it needs.
Yes. So we've actually programmed in the ability to operate in blind spots, so it can actually print around this steel I-beam here.
Just interpolation?
Yes, think of it as dead reckoning. If you like put a blindfold on, you start walking, it kind of know where you are until you go too many steps. That's what our robot's doing. So we do that, and then the other solution is the distance that these two can operate from is about 240 feet or 80 meters. And so we can cover an entire radius area with a radius of 240 feet, but that we often work in buildings that are bigger than that. And so the way it works is you take the setup, you move it to the next space, you set it up again, which takes about 10 to 15 minutes, and then you keep printing.
So there isn't an instance where you have more than one hexagon
Not
and
usually.
hands off, basically, when it goes around the house. It goes
We
around.
are
It's like
so
a cell tower
fast,
kind of.
yeah. So one of our learnings, we thought we would have to make an autonomous robot that would operate overnight on its own. It turns out this thing is so fast that they don't actually need that. No one's asked for it. Because they were thinking that it would take so long to cover the floor that they'd want to just like set it and then show up the next morning when it was done. It turns out that we can do it so fast that the guy can just stand here and be done in a couple hours. And so we don't really operate in that mode, we don't need to.
That might answer my question, but in terms of battery life, is that at all
4
a
hours.
concern for runtime?
Yeah.
So that's as much as one needs for a typical print.
Yeah, exactly. So the battery is actually in the back of the robot. I'll show you guys. So it's a Milwaukee battery, it's a standard Milwaukee battery. It goes in the back. And we provide 2 with the robot. Once it's on the charger, it's actually right over there. You can swap it out at lunchtime and keep going for the rest of the day.
Yeah, that's actually my next question. So where do you see your future product pipeline? Is this going to expand into other applications, or you have different robots down the road?
Absolutely. We are definitely a construction company, a construction tech company. And so when I first bought my first hard hat and I started looking at construction, like my lens is AI and robotics, because that's what I do. And I'm fascinated by human behavior and how do we capture it, how do we program it into a computer or a robot, and how do we automate it. And the reality in construction is that there's so much manual work, and there's so many bottlenecks to the construction process going off perfectly. And so I see all of these opportunities for us to bring more automation, whether it's robotic automation, whether it's software automation, to actually help solve a lot of these problems in the construction industry. It's the problems that I'm drawn to tend to be the communication problems. I started this by saying that ultimately construction is an orchestration problem. It's really about getting everyone on the job to do the right thing in the right place at the right time. What we're showing you here tonight, this is a communication tool. It's not a robot, it's not automated layout, it's better communication. Because this is how the people in the field understand what they're supposed to be building. They could read it, they could see it, and it's visible to them. And so the question is like, how do we get them even more information in order to do even better tasks without having to be slowed down looking for information or dealing with conflict? And so that is the opportunity, and whether that's through more robot solutions or more software solutions, that you'll have to wait and see. Yeah.
Can you eliminate, are you plans to eliminate the operator somewhere?
I don't know if we need to be honest.
You said 4 hours, that's 4 hours you wouldn't have to have someone there.
Yeah. So most of our operators are actually not doing much. I mean, like, I'm here talking to you guys like while this thing is running, right? So it's not like a full-time job for me to operate this robot. During that time, you know, a lot of our operators, you know, maybe they're on the phone, you know, coordinating materials delivery, or maybe they're training their crew how to do something. So it doesn't have to consume all of their energy to actually do the job.
So I'm guessing to go that next step will be a lot of resources and not worth the investment.
That's right.
Thank you.
Yes.
Speaking of not easy, your first check came the month before COVID. How did that affect things?
So, I mean, we had no idea that was coming. It was actually great for us because when after we did that first job, it was with one of those robots that you see on the table there in the museum. You see the difference between those robots and what we got here, right? We had a lot of development work to do. And so if COVID hadn't happened, we would have been continuing to do these pilots, continuing to get out there on job sites and failing, like the story that I told you earlier. And luckily, we'd done enough of those pilots that we kind of knew what we needed to build. And so what we were able to do was use COVID. So the entire construction industry shut down during COVID. I don't know if you guys knew this. No one wanted to be on a job site because they thought they would die. You know, they didn't want to be near people. They didn't want to get in a man lift with someone else. And so actually, getting robots on a job site was considered a positive thing because robots can't give you COVID. And so we actually leveraged that a little bit. But basically, we were able to use that time when the entire industry was shut down to take the pressure off of us trying to like get another pilot, to get out on another customer site, and just spend that time building. And so that was what gave us we had an extra half a year to a year to actually get the product to a much better state, so that when we could go back out onto our next job site, we were a lot better.
Do you just build by yourself, or are you still working with your customers to get the feedback? Because one of the challenges that we don't want to kind of run ourselves in the room is start building based on our own imagination. Yeah. So how do you handle that?
My favorite quote is from Steve Blank. If you know him, he's a Stanford entrepreneur. He says, "There are no answers inside the building, so get outside of the building." I take that to heart. I am talking to as many customers as I can fit into my schedule because I'm constantly learning what their pain points are, how we make their lives better, and what we should be building next to help them. You can't figure that out on your own inside the office. Yeah.
Can you talk about adoption as like a challenge across the chain? Can you tell me more details and share what exactly has to change on your end to adopt your robots?
Okay. Be easier if I had business. So one of the big changes that we ask our customers to do. So what I've shown you here, this is what we call multi-trade layout. And if you look on the ground, it looks like there's a lot of stuff here. What I look at what I see when I look at this printout is I see all these different trades information. So for example, I told you about these straight lines. These are the walls. Card reader is going to get installed by a low voltage electrician. The door probably gets installed by the drywalls, but it could be a different subcontractor. What else? The fire extinguisher cabinet gets installed by the fire protection sub. I might be wrong here because we actually have construction people in the end. We have ductwork, that's probably HVAC. We have, what else? ADA compliance, that's something else. This is a light fixture, an electric fan that gets installed by the electricians. Above ground, more light fixtures, more conduits, a junction box, an outlet, that's the electricians. We have soffits, those get installed by the firms. Okay, so every single one of those trades that I mentioned, today, if they were not using Dusty, they would need access to the floor, a clear floor, and they would have to make their own marks on the floor. Because they're responsible for installing their things, and so they're responsible for marking out where they go before they install them. And so something like this, you might give it to the framers for 2 days to do their layout. You might give it to the electricians for another day to do this layout, to the mechanicals for another day to do their layout, because you can't have everyone on the floor at the same time. They'd be stepping on each other's toes. And so each one of them is working off of their own information, their own shop drawings, their own files. They're using their own control points. Maybe some of them are measuring off of columns. Another ones are measuring off of the surveyor, of those 3 surveyor points. Another one's measuring off of those 3 surveyor points. And so you can see everyone is doing their own thing. And what we do is we get everyone on the same page. And so instead of each of them having access to the floor, using their own way of setting up and marking their points, and maybe coming into conflict, we lay out everything off of the same set of control points, off of the same file, through a process that we facilitate and coordinate. And that is a change to how they're doing things today. They get a lot of benefits from it, but it does require some change. And so that's part of what we help our customers through, is understanding how to operate that robot on my site, on this site. And they were going to kick us off the site. But, we said, okay, let's grab your son. He was like, I don't know, 20, 22 or something. And we'll train him how to use it. And so that was, so Brian Masters was our first non-Dusty operator. He's still one of our most biggest fans. He's actually caught on some of our videos now. And we stood there right next to him. And we said, tap that. Or, if something went wrong, we would open up the laptop and do some stuff in the background and then hand it back to him and say, okay, now you try. And we were standing there every single moment that he was operating the robot and teaching him how to use it. So it's not technically, him operating the robot. We were really showing him exactly what to do. But that was the first time that we did it. And we kind of had to. We were forced into it. As a result of that, we kind of had to accelerate some of the usability work that we had been putting off and making the system easier to use, and it kind of forced us to do more of that development sooner rather than later, but it was good for us because what it allowed us to do is go back to the Carpenters Union and say, we're building this thing, you're going to either get on board and embrace it, or you're going to get left behind. Because the people who are using this technology, this is coming, right? This is inevitable. We know it is. And so we found the right people who believed in us at the Carpenters Union to strike a deal with us. And they said, okay, we believe you, we believe this is coming, and so we're going to start teaching our members how to use Dusty. And so the Carpenters now run multiple Dusty classes a month. We've had hundreds of students come out of those training classes knowing how to use Dusty. And so now it's a really good partnership. Yes?
So, I love Steve Blank's point, by the way, also. So when you're going out to talk to customers to understand their pain points, who are they? And are they often the same decision makers, the purchasers? Or?
Yeah, well, there are so many different personas in the construction industry. That was one of the things I had to learn when I first started doing this. It turns out that a drywall contractor cares about something very different from a general contractor, cares about something very different from a developer. And then even within those types, there's there's the COO, there's the VP, there's the regional VP, there's the director, there's the project manager, project exec, superintendent, foreman, project engineer, right? And there are all these different roles. And so you have to learn what each of them cares about and how to talk to them. So it's kind of like learning a different language. You kind of have to just go full immersion and do it because there's no other way to learn it other than by doing it. And once you do that, then you know how to talk to them. And then that's how you know how to sell to them because you know what they care about.
And the ultimate decision maker is someone who's like the top of the contractors? Or?
Ideally, yes. You know, we're still working our way up. So we tend to sell project by project, but our goal is to get up to more enterprise level agreements, and we do have that with some of our bigger customers.
Are you planning to use AR to visualize what this is associated with?
There are companies out there that rely on QR codes that are printed on the ground that then give you an AR view. We've actually prototyped that in the lab, but it wasn't up to our quality standards, so we haven't released it yet. It is definitely possible. Go ahead.
During like your journeys of like dealing with like all the projects or tasks you have, did you receive any feedback from a customer that sort of like changed your business plan or like technological plan?
Yeah, all the time. Let's see if I have a good example. I mean, the union story that I just told you was one really good example, right? Let's see if I have another example. Some of the things that we build are in direct response to asks from our customers. So for example, one of the features that we have almost completed, it's in beta right now, is a floor flatness feature. I don't know if I can show that to you. Let me see if I can turn that on really quick. No, it's not turned on. So it turns out when you're building big buildings like data centers or hospitals, think about a hospital, you really care if the floor is flat or not. You don't want your gurneys rolling away because the floor is slanted, right? So you care a lot about the floor flatness. And we realized that so our customers were asking us, hey, can you tell us about our floor conditions? And we're like, well, okay, why would you need that? We had no idea. And then we learned about these problems with like hospitals and data centers. When you're installing all the racks in a data center, they all have to be shimmed to the right height so that everything's at a consistent height, for example. And so knowing what the elevation is at every point in your floor is really important to them. And so we realized that that was something that we could actually build with our current platform. Turns out that everywhere this robot goes, it's actually measuring not just the XY location, but its Z elevation. And so we can actually create you a heat map of this floor. And so we've been building out that functionality. We've piloted that with some of our early customers, and we're ready to release that. And that was directly because our customers kept asking us, hey, can you tell me about the condition of my floor?
So in your journey of going from the CTO who programmed the robot that delivered food in the hotel to the CEO of Dusty, what do you think that growth was for you? If there's anything you liked about it, or that was challenging for you?
Well, I think I have the best job in the world. I wouldn't trade this for anything. There's no way I would go back to a big company again. One of the things, I've learned a lot along this journey. I think the biggest growth for me has been on the personal side, actually. Just like learning how to work with people with different skill sets, people with different backgrounds, learning how to talk to construction people. That has been like really challenging and rewarding at the same time. Definitely not something I expected I would do when I was back at Cornell, right? Or even like, running a company was not what I imagined for myself. But I'm actually discovering that I really like it. It's a lot of fun. The challenges are different every single day. And so I'm having to learn new skills all the time. Right now I'm actually really enjoying vibe coding, kind of going back to my roots of CS. But I haven't coded anything in the last 7 years, and so I actually get to have fun now for the first time in a long time. I'm kidding. I actually think of building a company as kind of like building software, except that the puzzle pieces that I get to use are not modules and libraries, they're people. And so I'm assembling organizations, I'm assembling companies out of components, and hopefully they're not buggy, but sometimes they are. But for me it's about building, and what are the tools that I get to use to build, and doing it with people that I really, really like. And that's part of the best part of the job.
Going back a little bit further, sorry, what made you leave IBM?
I spent 11 years at IBM. I started at the Watson Research Center in Hawthorne, New York, moved out here to the Almaden Research Center in San Jose, and I was a manager, I had a team, I was in research, and so I was writing a lot of academic research papers and building systems and writing papers about them and contributing to academia. And I kind of felt like I figured it all out. Like it was, the same thing over and over again, build a system, write a paper, publish, repeat. And I wanted to do something different.
With that, I think, we want to have some time remaining to continue to network, but I just wanted to ask one last question. Since this is a Cornell alumni event, I wanted to ask you, was there anything that you learned at Cornell that helped you on your journey, and is there anything that the Cornell Alumni Network can help you with?
Yeah, good question. So my favorite class at Cornell was, I forget what class number it was, I think it was Physics 410 or 8. It was the Applied Physics Lab. It was an experimental lab where they basically had a binder full of experiments that you can run. You pick 5 or 3 or whatever, and you actually set up and run the experiments, and you document in a little notebook what you learned. And I actually got an award that year for the best experimental research lab performance or whatever. And I liked that because I think of myself as, nowadays I think of myself as an entrepreneur, but I really think of myself as a scientist. I think about when I'm building this business, I was just talking to my team earlier today, we're running experiments. So it's like the scientific hypothesis, what do you think is going to be true? How do you design the experiment to test it? Let's run the experiment, let's figure out what happened, and let's see if our hypothesis was true or false. That's how we build this business. It's just a sequence of experiments. Everything that we've done up until now, has been an experiment. And so I learned that with my AEP degree at Cornell.
Great. Well, thank you. Let's give Tessa a round of applause. And this event goes mingle. Feel free to speak with Tessa one-on-one. The next event that will be published, although maybe not technically a Cornell alumni event, is there's an event at the Computer History Museum on November 4th here in Mountain View by 2 Cornellians. One is a PhD graduate who wrote her thesis and book on Taiwan Rising, and she's Dr. Hong Hong Tin out of the University of Minnesota Twin Cities. And she's an assistant professor of program in the history of science, technology, and medicine in the Department of Electrical Engineering. And the moderator is also a Cornellian who I've met several times at Cornell alumni events, Hanson Shu. He's a curator software history. So just be sure that you're subscribed to CornellNorCal.com free email newsletter. And if you want to become a member, I forget what the annual membership fee is, maybe $40 or something like that. So definitely keep up to speed with what's going on, and if you certainly want to help and volunteer or know of other speakers that want to speak, let me know. So and enjoy the rest of the evening. Take some food with you. Finish some food. Don't want to take any with me. So enjoy the rest of the evening.
Thank you.